Function pointers in general are kind of old school. If you can accomplish what you see being done with a function pointer by using a lambda, that would be great. Another option is to use a template. Sometimes people use a function pointer so they can call the same functionality over and over again with slightly different starting places, and templates can be a way to get to that place as well. And the third possibility is to use virtual functions. If I have two objects, they are instances of different classes, and the classes they're instances of both derive from a common base class, and they've inherited some virtual function from the base class, I can call that virtual function and run different code depending on the kind of object that it is. So I might run different code for a checking account than for a savings account in that bank account universe. That's more object-oriented than having a function pointer called statement printer and having something like if account type equals savings, statement printer equals saving printer, else if account type equals checking, statement printer equals checking printer, and then somewhere else invoking that statement printer function pointer. And virtual functions are a better way to go. One way I can show that to you is to revisit that accumulate code in Disguise from way up at the top here that was gluing all the strings together. When they were actual char star strings, I glued them together using strcat. But with strings from the standard library, you may recall that you glue them together using plus. And accumulate uses plus. So since the people who wrote string have overloaded the plus function, the operator, I can now turn around and use accumulate for exactly that same purpose. I'll put it up here just so that the code is together. Obviously, instead of being a char star, I now want my all animals to be a string. And I'll call standard accumulate. I want to go from the beginning of the animals vector to the end of the animals vector. And the third parameter is the starting value. Now notice we printed out all animals colon space. Let's use that as the starting value of this accumulator. And then I can print it out without that prompt. And I'll just comment. Now notice all this other stuff disappears. All this figuring out how long the string needs to be and allocating it out on the free store here with the new and remembering to add one for the null terminator and all those horrible bugs that bite people who are thinking about working with raw char stars just disappears into this single call to accumulate. But does it work? Just need to pass a string rather than the literal quote quote kind of string. That builds. Because accumulated is a templated function, it gets upset if all of the various types being passed to it don't quite match. So if we run, a cowl elephant, okay. So we need to fix and have some spaces happening in there. Just as when I did the function pointer replacement for adding, say, half the value of each array, you just put a lambda in here. That takes two, in this case, strings. It was integers in the other one, and does the accumulation appropriately. The default, what accumulate will do on its own, is just return a plus b. And what we would like to do here is return a plus, say, a comma and a space, and then b. Let's try running that. Much better. Got a comma at the beginning. You can continue to play around with this however you like, including not having this starting point value for the string. But the need for function pointers really goes away because we have a function in disguise right here in the form of the plus sign. When you have good object-oriented design, whether it's a function called print or whether it's an operator overload, you have less need for things like function pointers. If you wanted to continue to have this thing down here where you have operation op is equal to subtraction, and then you use op here, there's still a lambda-focused way to do that. Subtraction, by the way, is another tiny little function, just like addition, up here at the top. I'm just going to make a lambda. Auto is your friend. You can't really type out with your fingers the type of a lambda, but it has one. Hi, I'm a lambda. I take an integer a and an integer b. In fact, let me stop typing. Let's go get subtraction and use it to build this lambda. Okay. Hi, I'm a lambda. I take an integer a and an integer b, and this is what I do with them. Just need to put an equal sign to give op this value, and a semicolon at the end. There's no red wigglies here. This code is happy. In fact, let's go up to the top and rip out these tiny little functions and this weird type def. This code is still happy. Build it. It builds. Run it. And we get the same numbers as before, 2257, 1127 for the adding up, and 2168 for subtracting the last number, in this case 89, off this larger total. This is more readable. This is a really small demo, but addition, subtraction, and operation were a long way away. You had to page up, page up, page up to find them. Here you can see exactly what it does. I mean, you could also have subtracted in place, but presumably there would be in a larger sample some kind of choice of which value to use for op. You can use the more readable lambda syntax rather than the almost completely unreadable function pointer syntax to achieve that same capability if you need it.